All right, aloha and good morning. So let me introduce briefly our panel members, and we'll go from there. So first off, would like to introduce Colton Ching. I think hopefully you've already noticed Colton's been up on the stage a few times, here from Hawaiian Electric. Next to Colton is Josh Wong, who's the founder of Opus One Solutions, and formerly with Toronto Hydro. And then introduce Makoto Watanabe-san and Kazuyuki Takada, so from NIDO. So thank you all very much for joining us today. So before we get going, I'll introduce myself. So Don Reeves with Silver Spring Networks. So before we get going, Watanabe-san will be going through a few slides to give us some background on NIDO and your Jumpstart Maui project, talking about electric vehicles as a form of DER.
Thank you very much, Mr. Moderator. Thank you very much. Aloha. My name is Makoto Watanabe. I am Executive Director of NIDO, which is a Japanese governmental organization, and we promote research and development. And thank you very much for this precious time to speak about our project in Maui Island. And actually, this is first time for my life to come here. So I'm very excited, and this island is very beautiful, and actually I enjoyed. I'm enjoying. So the project took place here on the island of Maui, which is world-leading island for renewable energy introduction. And the project main players are electric vehicles. Now, please allow me to speak about Jump Smart Maui, which is a demonstration project of a very advanced energy system. As you know, 35.3% of the total electricity used in the state of Hawaii in 2015 was covered by renewable energy. However, massive introduction of renewable energy may possibly cause various issues on the electric grid. It is crucial to solve these problems for the utilization of clean and sustainable energy. As a solution to these problems, the project of Jump Smart Maui demonstrated the storage function of EVs, which aims to stabilize the power system through a demand response and virtual power plant system, thereby accommodating the high penetration of renewable energy. More than 200 households of EV users participated in the project. An EV charger was installed at each household. Some of the households in Kihei district installed remote controllers which are capable of shutting down EV chargers, and water heaters from a distance, which is called home gateway. Output controllers of solar power, called smart PCS, and storage batteries for home use were also installed. As for the power system side, a device to control the consumer's equipment at the unit of lower voltage transformer and storage batteries for the power system were installed. These field devices incorporate automatic operation programs. In addition, an integrated DMS, integrated distribution management system, was introduced in the control room of the power utility to enable an organized operation of these field devices. The integrated DMS interacts and communicates with the energy management system of the power utility, which adjusts the power supply demand balance of the whole island. The top priority issue to be tackled in the project was an effective use of wind power generation, which tend to be a surplus during nighttime. EV users are known to charge their EV in the evening when they go home after finishing work. In order to leverage EVs as DER, we must find a way to control this peak demand flexibly. As a solution to this issue, the charging time should shift to the late night zone, where the wind power becomes a surplus. This also contributes to leveling out the peak time. Here is the result. We successfully shifted the peak time from 7 o'clock to 10 o'clock. 85 EVs are under control of a system called EVECC. For the actual operation, it is also possible to control the charging time based on the agreement with EV users. The next step is cooperation with the power system. The graph is an image of electricity demand on Maui Island. As I mentioned earlier, EV charging time tends to concentrate in the evening. We shift this peak by utilizing electric power derived from wind power generation to the late night. The next problem is solar power generation. Here in Maui, which has already introduced 40% of photovoltaic power at peak demand on a watt basis. Power generation by solar power increased sharply in the daytime. In this case, the thermal power generation approaches the minimum operation output. And in the evening, when the sun goes down, the rapid output of the system load needs to be raised. It is commonly referred to as duck curve, as you well know, duck curve. EVs also contribute in this case. In the daytime, we charge the batteries with sunlight, and in the evening, we utilize the discharge function of EVs and the charger to level the demand curve. This is actual data. During the period from midnight to 6 a.m., the EV charging increased to utilize the wind power. Furthermore, in order to cope with the sudden decrease of sunlight in the evening, it surpluses EV charging and discharges from dispatched EVs. We confirm that it is possible to contribute to solving the duck curve problem of the entire island in the future. According to the latest MECO's energy plan, Maui will make use of VPP with a capacity of about 25 megawatt in 5 years. I'm convinced the outcome of Jump Smart Maui project will contribute a great deal to the accomplishment of this energy plan. The project ended successfully in February this year. There was a great effort of the local stakeholders behind this success. The Maui County Mayor himself promoted the significance and importance of the Jump Smart Maui project to the citizens, as well as promoted understanding at the school education site. As a result, participating in the program by using EVs, the idea that we can make a good contribution to the Fall Island business has taken root. I am proud to represent NEDO and to have had the opportunity to have a demonstration project in this area. The project could not have been accomplished without the support from the people of Maui and Hawaii. I'd like to take this opportunity to thank all of the stakeholders, including the County of Maui, the State of Hawaii, Hawaii Natural Energy Institute, Maui College, Hawaii Electric, and the Maui Economic Development Board. Thank you very much for your kind attention. Thank you very much. And I think you have a lot of questions, and in the Q&A session, my colleague Kaz will join the session. Thank you very much.
Thank you, Watanabe-san. So it's been a fascinating day and a half so far, this conference. I'm a first-time attendee. I had really no idea of how diverse the set of topics and the set of speakers would be, and I'm really quite impressed, right? We've talked about societal challenges, we've talked about operational challenges within the utility, we've talked about commercial challenges, and we talked about a variety of different possible solutions. And something that ties the majority of these solutions together is something that we call the smart grid. As I was preparing for this panel, I looked for definitions on the web as to what a smart grid is, and I didn't find anything that I was particularly enamored with. So stealing a little liberally from our now chairman and some material I found online, I'll give you my definition, and then we'll dive in with the panel's take on this. So a smart grid is a system that connects any device that can control or measure the generation, consumption, or flow of electricity for the purpose of optimizing the performance of the electrical grid, making it more flexible and resilient, delivering higher levels of service to end consumers, and making the overall operation more efficient. That's what I believe a smart grid is all about. Josh, what's your take on that definition, and do you have anything to either add or differ from that?
Absolutely, thank you, Don. And great definition. Maybe I'll even take a step back and maybe talk a bit more strategically or philosophically even around what a smart grid is. I think a lot of the discussions we've had are on the DERs themselves, for example, smart solar, inverters, battery storage, electric vehicle charging, etc. But as Cheryl was saying this morning, actually it's the utility grid that ties all of these together. We cannot look at an integrated systems-based thinking with point solutions at the DER sites themselves, but we need to look at it from a holistic network platform perspective on how all of these devices integrate all together. So the definition is very much correct, but what I would add is with today's decarbonization or even deep decarbonization, smart grid very often leads to the convergence of several industries that were traditionally siloed. One is, of course, our industry or electrical industry. Now the second is the electronics industry. Of course, we're bringing smart inverters, a lot of sophisticated controls, then transportation, then even IT, data, telecom, etc. So smart grid is bringing all those lessons learned in advanced technologies, advanced business models into the electric power system infrastructure. So that's how I would typically see a smart grid. But even more so looking ahead, I would say smart grid is a transition of the grid to several different platforms. Traditionally, it's the physical wires, poles, cables, oil type of platform for delivery of energy, moving towards a second stage, which is a data platform, then intelligence platform. But I think with a lot of the recent talk about, let's say Fred this morning talked about the need for markets or the need for understanding the value of DERs, it's very quickly becoming a transactive marketplace for empowered prosumers. So I think this is the transition of the traditional physical grid to a smart grid to a transactive grid.
Excellent. Colton, you want to comment on kind of how the smart grid definition perhaps has even evolved over your time at Hawaiian Electric?
Meaning that I've been at Hawaiian Electric for a long time, Don. Yeah, Josh, I think, did a great addition. I think he used the word platform, and I just want to add the word choice to that definition, because really my sort of layman Baldwin High School interpretation of or definition of a smart grid, it's really taking a traditional electric grid, really transforming it into a platform that enables our customers and the partners that are all working off of that same platform to enable choices. And sort of the layman's non-technical perspective, that's how I kind of think of the grid. And everything both of you described in terms of the systems and the technologies are all the things that need to happen, right, to make the platform function that enables the choices. And I think for taking it to a very local Hawaii perspective, the obvious things that a platform and choices will give are things like the enablement of edge devices, right? Distributed energy resources, whether they're generators, whether they're storage systems like we've been talking about so far in this conference. But it's also enabling customer-facing solutions, right? Giving customers the choices to use some of the technologies that they invest themselves or work through with a third party to enable behind the customer's meter that then allows them to participate in a various set of programs with intelligence, with knowledge, so they can make informed decisions about not just how they consume electricity, but how they can provide services back to the grid. And because Hawaii is so DER and edge focused, I think we're going to focus a lot, when we talk about smart grid, we're going to focus a lot about those edge devices that enable all of those things.
Yeah, I think choice is absolutely critical, and I think that's something that has, I think, really been a big change in the utility industry, say, over the last 10, 15 years. Yeah, and for those not familiar, and I'll give you my perspective and welcome your opinion. Yeah, I think for the most part, utilities are accustomed to buying end-to-end solutions from a single vendor. All right, and that vendor's bringing in their equipment, their software, their network, their professional services, and then implementing that solution. But really the world is changing given all the forces we've talked about the last day and a half of the pace of technology change, the needed pace of innovation to meet demands of customers. And so now the utility is faced with the challenge of you now have not a homogeneous set of systems that you need to manage, but a very heterogeneous and very dynamic. And that must just be incredibly challenging for the utility to be faced with that plethora of choice.
Yeah, I couldn't agree more. I think utilities across the nation, including ours, and maybe in particular the utilities in Hawaii, is that you can't get a solution for everything from one provider. Right, that entity, that large conglomerate or solution provider trying to solve the very things we're going to be talking about in this panel, they may not exist, right? There are some very, very good players in there that can provide awesome solutions for specific pieces where they're bringing in innovation and their own technology and incredible domain knowledge in. But really, because this is so new and this is so dynamic, we were hearing earlier this morning about how things are changing so quickly. I think for the industry that supports the utilities, right, the providers, they too are, I think, trying to get ahead of the changing environment, the changing needs of the utilities customers, to try and provide that end-to-end solution. But at least as of today, I don't think there is a company or organization that can provide it. And so utilities like ours will need to take that role of being the assembler of some really great products and services from many, many different organizations, call them partners, and create the system and the platform and ultimately the organization to make it work end-to-end. As a utility employee, it's awesome, it's fun, it's exciting, but it's very, very challenging, to your point.
To add to that, I think Don and Colton, you raised a very good point of two integrated platforms that we are talking about. One is the utility as an entity, utility as a business model, where traditionally it's a pipeline business model. We call customers loads, right? Of course, we always quote that. And utilities buy power from bulk, deliver, transmit, distributes to end customers. Is a one-way pipeline business model. But now what you're looking at is a multi-way transactional model where you have both consumers, prosumers, and suppliers providing and consuming value on this utility platform as a business model, as an entity, as a role. But the other one that you're also talking about is because of this trend for the utility to move towards that type of platform model, the solution architecture within the utility is also changing. Actually, if I put on my old utility hat from 10 years ago, it's the vendors who are always pushing solutions to the utilities, and we have to adopt a bit of an all-or-nothing approach. But now it's often the customers, the policymakers, and the utilities driving that innovation, and utilities pulling together the various best of breeds from various vendors, various solution providers, and even from various industries. Like today and yesterday, we talked about integration of electrical with transportation, water, gas, etc. So in what we see from the industry right now, there's very often a talk of a system of systems architecture, where it's not just one system, one vendor, but how do we best integrate various vendors, various systems in some type of service bus type of architecture, both technically and as a business model.
So I want to touch on that, and if there's any IT system integrators in the audience, I'm going to apologize in advance because I'm about ready to go offend you a little bit. But a lot of these projects tend to become mired as gigantic integration projects, and in some sense, often complexity is encouraged by the integrator because there's more billings associated with that. But one of the ways to cut through that is to actually focus on standards, right? So one great example of a standard is the ANSI meter socket, right? You can unplug a meter, plug a new meter in, and you're guaranteed it's going to work. But there's a variety of other standards that are coming, and I'm sure, Kaz-san, as part of your project, that standards played a role, and you probably have a perspective on how they might influence the smart grid moving forward.
Yeah, the standards is really critical, and in Japan, utilities decided to utilize the open ADL protocols to communicate with the virtual power plant or DL aggregators, so that the business can easily get into such businesses. Without the standards, utility will create each own specific specifications, and the vendors have to modify the services or products for the specific utilities. That doesn't make sense. And also, in our project in Hawaii, based on the requirement from the Hawaiian utilities as Maui Electric, the system utilized the OpenADL as well to communicate with the utilities. And under that systems, the project system is communicating with each customer's equipment by using SEP 2.0 US standards. Even though in Japan there's another standards called EcoNet Lite, but we didn't. We decided not to use the Japanese-oriented standards, but in the United States ones. So it's important to adjust the models based on the regional requirements. This is the important for the businesses to get into the other markets.
Great, thank you. And I think standards will continue to evolve. I guess, Colton, I'd love your thought on kind of the utility perspective on standards and what role should the utility be playing in driving standards forward.
So it's a really good question, because especially when you ask the question about the role and applicability of standards in the smart grid space, because you have two almost competing sort of interests, right? The interest to establish standards so that many different people can come in and connect to the same platform, not have be tied to any specific vendor or particular system or way of doing things. But at the same time, this is an area maybe more than many others, meaning smart grid, where the pace of change is happening very, very quickly. And as soon as someone comes up with a great idea of how we should be doing something, the guy next to him has just come up with an even better idea. So for myself as a utility, I think we have to be very pragmatic in how we deal with both, that we need to rapidly evolve, be in a position to take advantage of new technologies, which includes new standards, but yet really extract the value of adopting standards, as Kaz talked about as one example, that allows a utility and everyone else that's partnering with the utility and all the customers that participates in a program understands that this is a standard that will be used, and if that standard is open where multiple solution providers and equipment manufacturers can all use that same standard, it gives customers and third parties more choice, right? Which is back to the discussion earlier. So that's how we take a look at it, but also pragmatic in the fact that, you know, it's not just the electric industry, but telecom, you know, EVs are facing this right now, electronics, consumer electronics, right? We've all have really good and bad examples of where, as consumers of devices, we've made really good and really bad choices on standards.
Yeah, I got to go find my Sony Betamax.
That's right.
Let's pivot the conversation and let's talk a little bit about security. So in some sense, security is kind of like motherhood and apple pie, right? I think everyone agrees that everything needs to be secure. I think there's some basic awareness that there are risks if things are not secure. I would hazard a guess that most people in the audience don't really understand kind of the nuances because it's inherently a complicated topic. But let's talk about, you know, what are the sort of security threats given, you know, your expertise, the expertise on the panel. What are the security threats that you worry most about? And I'll start with Josh.
For sure, but you from the Silver Springs Network side, you definitely know a lot more about detailed security standards than I do. But maybe I'll take a step back and again talk about it from a more systems holistic view. Security is always a risk management exercise. There's no way, even with the ISOs or with nuclear power plants, etc., you can fully secure something. Even Yahoo's hacked. Even a lot of the big IT companies still today face a bit of security threats, and I always see security as one-upping each other. So the moment you up yourself, then the threats go higher as well because you're challenging more from the other side as well. That's why it's always about risk management. But I see also security from three different angles. One is a physical security to protect, of course. Traditionally, well, not a lot of things communicate, and for those things that communicate, we put them right beside a high voltage or medium voltage cable. So if you try to break into that box, you might get zapped. So that's a great way of securing it, or putting it inside of a fence. But now we are extending communication.
Is that what they do in Toronto?
That's our security threats. So how we test the security is drive by with a chain, and throw it on and see if this grid self-heals itself. Okay. So. But yeah, it's physical security is the best way to security. But now as we extend the communication boundaries beyond the traditional protectable physical barrier, we are opening up a lot more risks. The other is cybersecurity, which is probably the hottest topic today. Again, traditionally, utilities don't have a lot of things that communicate. Anything that communicates with will be in the red zone, what we call the red zone, so within SCADA protected proprietary systems that nobody can really get into unless they get close to high or medium voltage. But now again, as we push security or communications through SEP2 or through OpenADR or others into the edge, we are exposing a lot more threats. And now the new threat that we will see is we're not just collecting AMI information for the sake of metering, or we're not just communicating with DERs for monitoring control, but we are tying these systems that are at the edge into the utility red zone as well to run inside the DMS for power flow, for optimization, to run some type of value analysis or pricing. So we are definitely putting systems that are traditionally siloed and protected and secured together. And if we bring in weather forecasting, ISO data, etc., that increases the threat as well. But another way to mitigate against that, as well as when we talk about data transparency, et cetera, do we always want to expose the actual grid operations data? Because let's say how the voltage, the capacity in each line might be highly sensitive to a secure and resilient operation of the grid. So something that we have been doing in New York Rev is, and even in the other parts of the Northeast, is instead of sharing actual power flow data or voltage data with the end customers, we share pricing. So there are many ways to anonymize the data in addition to aggregation, but if pricing becomes a proxy for how the DER should operate with respect to the grid, that becomes a very secure way, because there's no way to really reverse engineer back to actual power flow signals, which might affect reliability, resiliency. The third one, I'll just throw it out there, which I'm sure this crowd is more electrically oriented, but it's on power system security. So including the traditional metrics of resiliency, reliability, resource adequacy, power quality, all that together rolls up into power system security. And when we look at 100% renewable target, I would say in this particular context in Hawaii, that's actually being threatened the most, because that's with that high of a percentage of renewable generation, all of the above metrics will be challenged.
So I'll just kind of summarize a little bit there to make sure the audience heard it, because I think there's some really, really key points you made. I mean, first off, the notion of securing a device that is physically available 24/7, right? Most of us would never think about leaving our laptop outside on our porch, available for anyone to walk by and do whatever they want to it. But essentially, all these assets we're talking about, whether batteries or meters or PV systems, right? They're all out there, right? They're physically out there in the weather and the environment, which is its own set of challenges, but they're actually out there and available to attackers. So that's just a gigantic challenge. And then I think the nature of the evolving security threats, right? If the smart grid is not able to itself evolve and be updated and upgraded over time, then that means that inherently you're going to have an insecure system at some point, even if you start off secure. Now let's then pivot again to think about the consumer side of this. So I guess I'll ask Colton and then Kasan, kind of what are some of the challenges related to that you've heard from your customers about, their information privacy, and how secure is the information you're gathering from their home if they've got a smart meter on the side of their house or a PV or battery system that's giving telemetry?
So on Oahu, we have what we call an initial deployment of just over 5,000 AMI meters on several circuits on the island. And as a general rule, those customers of ours who have those meters installed at their homes and businesses have been actually very good about a discussion around data and data privacy. But I think very much like other utilities and experiences with customers, when we had an initial engagement with these customers and had initial talks, there was a lot of concern, right, around privacy. I think the key to your question around having not just an adequate or a proper level of data privacy is also how do customers feel about it, right? It may be an appropriate level from a legal perspective or something like that, but may not necessarily be something that a customer is comfortable with or what a customer may think may happen with the data. So I think the key to data privacy is doing some of the things that Josh talked about in keeping it anonymous or aggregated or other ways to try and make it not individual data. But I think the other part that really is critical is to have those engagements and discussions with the customers before the data is created, right? To really have an understanding of what the data is, how it will be used, how it will not be used. And I think that will go a long way towards making people feel more comfortable with it. Having said that, I won't call her out, but I had the pleasure of sitting on my flight over here to Maui with one of the attendees out here in the audience. And she said something that I just want to kind of just give my own spin on. When in today's modern age where you're on Facebook and you're tweeting, and I'm not talking about the president, and you're emailing each other and you're texting each other, and you are a customer of utility who's participating in different programs. I think societally, we are starting to change how we view our privacy around our individual self, including data. And I think there's this shift, and I think there needs to be this shift where we all become a little bit more comfortable around sharing at least some critical information about ourselves in a way that's not harmful, but in a way that provides the data to the right point, right, to the right system, so that the data can be used constructively to enable something or make something more efficient. And that's going to take some time. It's human nature. It will be an evolvement. But I think that's a really critical non-technical aspect of making everything that we're talking about in a smart grid to actually work.
Yeah, well, there's an alliance that probably some of the audience members are familiar with, the Green Button Alliance, right, that focuses on standards for how a consumer can get access to their information and also how they can have it shared in a secure way with whomever they like. And of course, the results of all that are actually many consumers are actually willing to share the information, provided that they're getting some benefit in return for that. So I think everything you just said is exactly already proven out in the market. So Kaz-san, your project dealt with something really interesting from a privacy perspective, right? You're actually touching people's automobiles and modifying, right, the charge level with the car. So what were any of the challenges that you faced there with your customers of that system?
Right. This is really important issues for the project. And our partners in Maui, especially Maui Economic Development Board, made a great effort on engaging the customers by doing a lot of lectures to the potential volunteers of EV users, what the project is and how technology applied to each customer's assets. And also, definitely the project has to take a contract with each volunteers. We will not use this data for what, and we will use data for what. This type of education was made by my partners, and that made a great success for the proceeding project. So once people acknowledge how the system works and how the data will transfer to the system and how to be secured for that, people begins to think about, the participate in the program. So engaging and education to the customers is really critical. Of course, the system itself is trying to be more secure, the technologically and the system-wide. We also utilize the US standardized process for how it is secured. The utilities requested the procedure to check how it is secure. So our contractor Hitachi are trying to utilize one of the Japanese hackers, to try to, offense the systems and make sure if it is okay or not. This type of procedure was made through the projects.
Right. Well, so I think a consistent theme of your answers are really around customer engagement, right? And that communication, we heard that this morning. I'd say that's been a hallmark of, I know the customer projects with which I've been associated, is that focus on early, often, and repeated communication with the end customer, really taking their questions seriously, right? And not taking anything for granted around what the customer understands, what their concerns are. And ultimately, I think the utilities that have been most effective at engaging with their customers have been most successful with the satisfaction levels from their end consumers with those rollouts. All right, we've got a few minutes left here. I want to turn over to some questions from the audience. So follow-up, Kasan, will there be a follow-up Jump Smart project?
Yes, definitely. Unfortunately, our funds to the project has over, but it is really important for NATO as a kind of a government organizations to keep the momentum of the activities. So we will try to hold some kind of workshop by gathering expertise from the worldwide to discuss the results of the project. Then we will be able to get some comments or suggestions or any good questions to us. And it will make sense for the players such as Hitachi or Maui Electric related entities to consider the next step of the activities. This is what we are trying to do.
Great, thank you. So Colton, I'm going to give you a tough one here. So can you speak to the value of a full-scale smart grid rollout and how accessible that data will be, how that will ultimately benefit customers? So I think kind of implicit in that question is probably some notion of full-scale versus not full-scale.
Right. It's actually a great question and very timely. We're working right now on a grid modernization strategy that's contemplating looking at, amongst other things, a smart grid deployment that is not full scale necessarily, or not presumed to be full scale at the onset, but rather one that is designed and ultimately deployed on a more modular fashion, one that is done responsive to a program being developed and interest and uptake in that program by either by third parties or by our customers directly. And it's an interesting endeavor that we're going on now because it's quite different from how smart grid deployments have been done, at least historically amongst utilities. And it provides, I think, some new and different technical challenges in how do you build that communication infrastructure? How do you provide the back office functionality on an expanded, more dynamic basis? And many things that I'm sure that I haven't thought about yet. But it also, on the flip side, provides, I think, some great opportunities to really maximize the flexibility of ultimately what you roll out, both in terms of the specific technologies that you use, but also in terms of the services and functionality that the platform you create provides to customers. And ultimately, I think that will give us meaning Hawaiian Electric companies, an ability to really, keep the value of what we deploy fairly high because it's there just for those customers that elect to participate in some program that requires some of the functionality we've been talking about from a smart grid, and yet can keep that deployment costs lower because we don't have to deploy it everywhere. Now, the incremental cost may be a little bit higher, but it I think can help keep our total costs lower. And it remains to be seen how much of this capability that we provide will be used by all of our customers. Is it going to be something where nearly all of our customers use some level of service from the smart grid that we create, or is it going to be more of a situation where a portion of our customer base become very high users of multiple functions on our grid? And it remains to be seen where we're going to go, but we want to be able to create a platform, have a strategy that allows us to be responsive to either long-term outcomes.
Great, thank you. One final question, I think, and I'll direct this to Josh for starters. How do we encourage utilities with smart grids to provide plug-and-play access to the private sector?
Good question. Plug and play to what? There's many ways. I think the key is to understand the objective of what you're gaining access to. Of course, there are some things that the utility must maintain to secure the grid in terms of reliability, resiliency, et cetera. But I think, if I understand correctly, the question is plug and play to information that allows a marketplace to happen and to allow third parties as well as customers to extract and provide value to the grid. And I think that speaks to exactly to, for example, standards such as OpenADR SCP2, but even really exposing where or how to properly provide and extract value to the grid. I think that's really where my interpretation of the question is. Something I would like to quote this morning from Michelle's keynote, which is, you need the numbers do the talking, right? And today, utility has been flying blind because of the nature of the system for the past century or so. In an average North American feeder, you have less than 0.5% visibility over grid parameters. With AMI, you bring a lot in from the edge, but the actual lines, transformers themselves are limited to only like a handful of SCADA points or so. So how do we go from blindness to seeing, and how do we go from seeing to controlling, and controlling to optimizing, and optimizing to evaluating? I think we have to work through that entire chain, and that's why really I think something like a DERMS or enhanced type of control system, the whole market valuation of DERs by location, by time, is essential to expose that value. And as I mentioned in a previous response, if you share price schedules, it's a lot more secure and private than sharing power flow parameters. So is there a way that we can exchange securely and privately both command control monitoring, but also value signals, so that customers, prosumers, and third parties, including aggregators, can fully understand how to interoperate with the grid to create a bit of a win-win situation between the network operator itself and the empowered prosumer. So I think that value holds the key.
Great.
I know we're running a little bit long, but just want to add to this question. I think it remains to be seen whether something ultimately will become plug and play in the truest definition. I don't think any one of us, or maybe everyone in the audience, really has the crystal ball that can predict if that will happen and how. So I think the notion of plug and play is a good example of where, as a utility, we really need to innovate to solve for this question. This question being a good example of that. And we're trying out piloting, testing, experimenting, or deliberate experimenting various technologies on our grids today. JumpSmart Maui is just one example of the things we're doing, and the kinds of testing that we're doing right now, and the pace at which we're doing it. We recently looked at doing a low voltage static compensator project with a company called Varantech, and we took it from an initial meeting with the company and their technology, identifying that that technology can serve in a very different role, and getting stuff designed and ready for deployment in 6 months. And it's those kinds of things that we need to do at the Hawaiian Electric companies, at others as well, and other utilities, to really answer that question. Can we really get it to the point that it's plug and play? It's a great vision, and if we can ever get there, it'll be wonderful. But there are many open questions and challenges to get there, and I think that's just literally part of our job and our mission to go figure that out.
Well, I think coming out of this panel, we've identified maybe two possible themes for next year. We could have plug and play, or we could have choice. Maybe those are both interrelated. Well, I want to thank the panel members for your participation. I want to thank the audience for hanging in for a few extra minutes since we're between you and lunch. I thought we had a great conversation on smart grid, and hopefully it was illuminating for the audience. Thank you so much.